Hey, welcome to another session of Practice Help on Geometry with Mr. H. This is lesson 1.16. This is dealing with more symmetry. This is about rotational symmetry. Remember, you stick a pin in something and you start spinning it around. If you can get it to match up in terms of its position, and sort of click into place the same way it was before you get around to 360 degrees, then it has some degree of rotational symmetry. Okay? All right. So it says for each figure, identify any angles of rotation that create symmetry. So stick a pin in the middle, start turning it. If you can get it to lock into the same a position that looks the same before you get to 360, then great. Write that down, right? You can use the text tool right here, right? All right, great. Same thing for this one, right? How far do you have to rotate it before it looks the same? Same thing for this one. How far do you have to rotate it before it looks the same? All right. Task 12. A triangle has rotation symmetry, right? A certain triangle that they're asking you to imagine has rotation symmetry that can take any of its vertices or corners to any of its other vertices. Okay, so as I spin this triangle, it can click in to the position of the other two corners before it gets back to itself. Okay, select all the conclusions that we can reach from this given information up here, right, out of these three statements. Okay, which ones have to be true? Pause the video and answer the question. Task 3. Here is a beautiful flower. Oh, okay, yeah. Looks more like a four-leaf clover-ish sort of kind of thing, but not really. Anyway, select all the angles of rotation that produce symmetry for this flower, right? This is a four-petaled flower, and we want to look at how far do we have to rotate this before it clicks in, right? And if I rotate it, it's not just the first time, but how many total degrees I've rotated it, right? So which ones work? Okay. Next, task 14. Identify any lines of symmetry that this figure has. Okay. And use the line tool, right? This one right here. Okay. And just put them right on the diagram. Lines of symmetry have to deal with a reflection symmetry. Okay. So this is just a refresher on that. Task 15. A triangle has a line of symmetry. Select all conclusions that must be true, right? If it has a line of symmetry, which of these things have to be true? All right, pause it, go through each one, try and figure it out. If need be, grab a scratch piece of paper and draw a triangle that you can definitely split exactly in half. Okay, and then figure out which of these statements must be true. Okay. All right. Task 16. There are four triangles that have each been transformed by a different transformation. Which transformation is not a rigid transformation? Okay, so take a look at all of these and try and figure out which one is not a rigid transformation. We know what the definition of rigid transformation is. All right, so here we go. We've got another. It says match each directed line segment, that's these guys in the middle, with each of the translations from polygon P to polygon Q by that directed line segment. Okay, so I'm going to just grab this just to move these out so that I hopefully can see this a little bit better. Oh, no, I can't move that. Oh, it's not going to let me move it. Well, that's no fair. Oh, well. But I can definitely move these. I was hoping I was going to be able to move these because this thing's kind of in the way. Oh, there we go. I can zoom out. There we go. So you're going to grab each one of these and put them where they belong, whether they go with this one, this one, this one, or that one. Okay. You're just going to move them around until you have until you've matched these guys, these vectors, up with the appropriate translation. And that's it.